Okay guys, so I'm not going to be in class today, but what you can do is just follow this video and go step by step and make sure you take your notes. Um, Make sure you put what you do in Book Creator, and also make sure you take pictures of your work and upload it to Canvas. That's how I'll take attendance for the day. So you're going to practice inverses algebraically. We are going to test next week. So we're just going to continue to practice inverses today. The standards we're covering is finding inverses algebraically and using compositional functions to verify inverses. So what you're going to learn is how to find the inverse of a function algebraically and how to prove functions are inverses algebraically. These vocabulary words, you can write them down and put your definitions in your book. We've already gone over these words, so you can write them down and put them in the book from your other lessons. So let's go ahead and try this out. It says, what is the equation form when the line is reflected over y equals x? So this is asking you to find the inverse of this function. So we're going to use, please excuse my dear Aunt Sally, we're going to use our order of operations to help us break down the parts of this inverse function. So here, we're going to find out what's going down. And then we're going to find out what's up. So do I have any parentheses? Yes, I do. And inside, I'm going to go inside those parentheses. And I notice that I'm adding 4. All right, I'm done with parentheses. I have an exponent. And so I'm going to say my exponent up there is called Q, because that's 3. And then do I have some multiplication and dividing going on? I do. I'm multiplying -3. So I'm going to say multiply -3. And then divide 5. And then from there, do I have any adding or subtracting going on? I do. And I'm adding 1. So now I'm going to take the inverse operations of these. Sub 4 cube root, divide 3, multiply 5, and subtract 1. So now from this side, I'm going to write my inverses. I'm going to find out what's going up to write the inverse. So f -1. F inverse x would be x minus 1. Multiply that by 5. Divide by 3. Take the cube root. Make sure you put the 3 right here. And then we're going to subtract 4. And that is the inverse. Now this next part, it is telling us to prove that the functions are inverses. In order to prove that these functions are inverses, we have to show that, and I'm going to call y f of x. We have to show that f of the inverse of x equals x, and we have to show that f of the inverse of f of x is also equal to x. If they both equal x, then we know they're inverses. If they don't both equal x, then they're not inverses. And this is called doing the composition of these two functions. So this one tells me to just write down the f function. So -3 over 5, x plus 4 over 3 plus 1. And now it's telling me to substitute in the inverse function in for the value of x. So I'm going to write the -3 over 5, and then I'm going to go to this inverse function. Wherever x is, I'm going to put the inverse function in. So we get x minus 1 times 5 over 3 minus 4. And then I'm going to put the plus 4 back, close that cube, and then plus 1. Okay, so I'm going to do what's inside of the parentheses first. These go away, so those two go away, and I'm left with cube root. Well, you know what? I'm going to go ahead and show you all the things to go away to simplify this very quickly. So this goes away. The -4 plus 4 goes away. The cube root goes away with the cube up here. So I'm left with, inside the parentheses, 5 times x minus 1 over 3. And all I did was move the 5 to the front because we generally don't write the coefficient in the back of the parentheses, but it's not wrong if you do it that way. And then here, negative 3, and that 3 goes away, 5, and 5 goes away. So I end up with negative oh, I forgot to put negative 3 here. This should have been divided by negative 3, so this needs to be negative here. Okay, don't forget that negative sign, guys, like I did. Okay, so that goes away. And then I have left here x minus 1 plus 1, and those go away, and I'm left with just x. So I'm good with proving that if I put the inverse function into the original function, I end up with just x left over. Now I need to prove that if I write the inverse function down, x minus 1, 5, negative 3, minus 4. And then I need to put in for x the original function, so I'm going to say negative 3 over 5 x plus 4 cubed plus 1, okay, minus 1, right, and then I get 5 over negative 3, and then minus 4, okay? So I'm going to go through here and start breaking stuff down. And something should have been, oh, I'm good. All right, so this goes away. The 5 goes away with this 5. The cube goes away with this cube. The cube root goes away with the cube. And then I'm left with x, the negative 3 at the top. Negative 3. X plus 4 minus 4, all right, over negative 3. So this goes away, and then these two go away, and then we just have x. So we say the functions are inverses because f of negative 1, inverse of the function, is equal to x, and f negative 1, f of x is equal to x. And then you're done. Alright, so what I want you to do is pause the video, and I want you to try this problem, and then when you get to this one, play the video back. Alright? So this question is asking, what is the equation formed when the line is reflected over y equals x? So this is also again asking you to find the inverse. And we're going to use, please excuse my dear Aunt Sally again. So we're going to find out what's going down, and then we're going to find out what's up. So do I have any parentheses? Nope. Do I have an exponent? Yep. And it's going to be cubed. That 3 up there is cubed. Do I have multiplication and division? Yep. I got this fraction sitting here. So I'm going to say multiply negative 6 divide 7. And then do I have some adding and subtracting? Yep. I got add 2. So here I'm going to put cubed root because I'm doing the opposite or the inverse. Divide negative 6, multiply 7, subtract 2. Alright, and then from here f of -1, the inverse is going to be x, and we're going to find out what's going up. X minus 2, multiply that by 7, divide that by -6, and then we're going to take the cube root, and we're done for the inverse. So now we need to prove that they're inverses. Well, I want to say y is the same thing as f of x. So I need to show that f of the inverse function is equal to x, and then when I take the inverse function and put in the original function, I have to show that it equals x as well. So I'm going to write down the f function, 6 over 7x cubed plus 2. Then I'm going to go and put in the original function, or the inverse function for the x. So that was this, x minus 2 times 7 over -6. Close that up. Cube was there, and the plus 2 is already there. I'm going to go and start breaking things down. This and this go away. And then this and this go away. That and that go away. And we're left with x minus 2 plus 2. And we get x on that side. So now in this one, it's telling me to write down the inverse function. So that's what I'm going to do. X minus 2 times 7 over -6 cubed. And then everywhere where I have x at, I'm going to put -6 over 7. -6 over 7 x cubed plus 2 minus 2, 7 over -6. And from here, I'm going to go ahead and do my math. This goes away with this, and that go away. This goes away, and this is going to make that go away, so we're left with x. Alright, so we're going to say the functions are inverses because equals x and equals x. Alright, and there we go. Alright, so I want you to pause this video and go and try this problem, and then when you get here, when you get to this one, push play on the video again. So this next question is telling us to find the inverse of this function, because if it's asking me to reflect something over y equals x, it is asking me to find the inverse of the function. Alright, so we're in a situation where we still need to find out what's going down and what's going up. But before I do this, because this fraction now is over the whole thing, I'm just going to rewrite this as x over 5 plus 2 over 5. That's what I'm going to do. I'm going to rewrite it as a two separate fractions instead of one. And now I'm going to go here and find out what's going down and what's going up. I'm going to find out what's going down first, and I'm going to use my, please excuse my dear Aunt Sally. Do I have any parentheses? Nope. Do I have any exponents? Yeah, that's a 1, but it's not going to change anything. Do I have any multiplying or dividing? Yes, I do. So here I have multiplied by 1. The x is being multiplied by 1. And then the 5, the x is being divided by 5. And then here I am adding 2 over 5. On this side, I'm finding out, I'm doing the inverse, so I'm going to divide by 1. And when you have 1, you really don't have to write it, but I'm just doing it for the sake of multiply by 5, and then subtract 2 over 5. All right, so the inverse, I get it from this side, and I find out what's going up. So we get x minus 2 over 5. Multiply that by 5. And then we can put divide by 1. And I'm not going to write the divide 1 because 1 doesn't change anything in the problem. So if you notice here, this problem can be simplified. So if I did x negative the inverse, 5, I can distribute, well, I can distribute the 5 to both of these problems. So I end up with 5x minus 10 over 5. And we will end up with 5x minus 2. So when you have a fraction like that, go ahead, because you might not see the answer in this form. You may need to distribute so you can see your answer in this form. All right, so now I need to go in and do the next part of the question. So it says prove that they are inverses. So I need to prove that f of negative 1 x equals f inverse of f of x. And both of these need to equal x. So I'm going to hold the x function. I'm going to write it down. And then for the inverse function, I'm going to put in, and I'm going to use a simple form of it, 5x minus 2. So 5x minus 2, and then I'm going to put plus 2 over 5 in there. You do the math, that all goes away, and we're left with x. Okay, so here I'm going to write down the inverse function, which is 5x minus 2. And then I'm going to go and substitute in the f function where the x is at. And then minus 2. So this goes away, these goes away, and we're left with x. So we're going to say they are inverses because f of the inverse function equals x, and f of inverse is also equal to x. And that is that. So pause, go through, knock out the rest of these problems. So that was the last set for me to do with you. All right, and so I'll see you guys in class. Hey, make sure you put your work in Book Creator and make sure you upload it to Canvas. That's how I'm going to take attendance. So you can take screenshots and upload however you want to do it. But go through here and knock this out, and I'll see y'all later.